Okay, um, now we're going to very quickly go through a quick summary of 16.1 and 16.2. Yep, techniques of integration. There are 5 points I would like to say. First, integration is the reverse of differentiation. So we got to learn them together. All right, I'll elaborate them point by point later. Next, we're going to talk about standard form. Some basic standard form they are not in MF26. For example, integrating EX, etc. etc. Point number three is Trigo, which I know a lot of us are not so comfortable, but it's a major part of integration. All right, and again, I go back to point number one. Right, it is the reverse of differentiation. If you know a differentiation well, then integration is half the battle won. The fourth point I'm going to talk about is what I call integration of the form 1 over, this is a quadratic, and 1 over square root quadratic. All right, and this we got to make use of the formula list. And lastly, is of this form, it is a linear over quadratic. Let's jump straight into this. First point, integration is the reverse of differentiation. So we learn them together. I repeat one more time, we have to learn them together. All right. So I give you an example. If I know that I differentiate sine x, I get cosine x. I will know that integrate cosine x, I get sine x. So we learn them together. We don't learn them separately. All right. Let's be very clear. So if you differentiate sine x, you get cosine x. Therefore, you integrate cosine x, you get sine x. You will make use of this idea very, very often. Very often. I repeat, very often. Right? So we have to get it clear. And furthermore, in the practices that you get, you will always get different kinds of questions. Then many questions students will ask me which formula do I use? Unfortunately, there is no magic answer. You just have to think of integration. All those point number 1, 2, 3, 4, 5 are all inside your toolbox. Then at the appropriate time, you take out the appropriate tools. Now, if you don't know what is in your toolbox, you will never be able to take them out. You've got to know what is inside. So you've got to familiarize. Then, if you are familiar, then you will know which one to choose from. You run through in your mind, what is it? What is it? What can possibly match? You see you see a nail, then you take out a hammer. Something like that. But will other tools work? Maybe. So you got to familiarize. Enough of analogy. Let's jump straight into point number 2. Standard form, they're not in MF26. So, what is the first thing? A. Now, you should know how to integrate this one. Integrate x to the power n. I want to emphasize n is not equal to -1 for this formula to work. Right? Now, this is x to the power n plus 1 with n plus 1. Why does this work? Because you differentiate the right hand side, you will get the left hand side. Correct? You differentiate right hand side, you will get left hand side. Now, a little bit more complex version, or rather an advanced version of this formula is this. It actually means that if I integrate f prime x fx to the power n, what do we get? We get fx to the power n plus 1 over n plus 1. Now, I think this is not difficult to understand as long as you know that you differentiate this. Differentiate right hand side, you will get your left hand side. The f prime x is because of chain rule. Right? The f prime x is because of chain rule. So, can I give you a quick example? This, right? A very quick example of an application of this. I always like to use sine and cosine, and if I give you the example, I cannot use it. Example. If I integrate Sine x, sine 7x. It is quite obvious that this is sine 8x. This is my f prime x. Sine x, sine x is my fx, not sine 7x is my fx. Alright, this sine x is my fx. Then you get fx to the power 8 over 8. Clear enough? This time, let's take a look at this one. If n is minus 1, that means you have x to the power minus 1. I treat this part B as a special case of part A. Part A, I already emphasized, n cannot be minus 1. If n is minus 1, we are actually integrating 1 over x, which I think you know that it is ln x plus c. I shall not belabor why is it mod x. If you need to know, if you want to know, come and see me, or you look at the notes, it's there. I will not introduce this in this video. Alright? But I can do it with you when you come and see me. But just remember it's mod. Just remember it's mod. Right? Therefore, if you integrate f prime x, fx to the power minus 1, what do we get? We get ln mod fx. Now, very often, we would write this one. I need all of us to be comfortable with either one, because sometimes you may not see that this one is actually the same as this one. I'm sure you know now, but when you see the question, you may not see it. I'll give you an example. Now, what if I need you to integrate, say, 2x squared plus 7. Right? So in this case, it's quite obvious. The numerator is f prime x, the denominator is fx. F prime x over x. You get ln x squared plus 7. Now in this example, I can simplify it a little bit more to get mod. Because x squared plus 7 is always positive, I don't need mod. But you need to justify that since x squared plus 7 is positive for all x. That's so far. Third kind, B. Integrate dx. I think you know it is dx plus c. Which means that f prime x, fx, dx equals to df. Why is this true? Again, you will differentiate this. You will get f prime x df. Okay? I think this is simple. I don't think you need an example. Yeah. Let's move on. Point number 3. Integration involving trigo functions. I think the standard form, I don't think I need to say a lot, alright? But there are few formulas that are in the formula list. There are few formulas that are not in the formula list. At this point, can we refer, take MF26 out, alright, and you take that and you see for yourself, and then you as I go through, you look at your formula list beside you. You can pause the video to go and look for your formula list before you resume the video. Okay, I hope that you have your formula list in front of you. There are few formulas that are not in formula list. So I would just say not in MF26. Integrate sine x, dx, integrate cosine x, dx, integrate secant square x. And you also need to know this one. Integrate cosine square x dx. Now the first 3, I leave it to you to know. I don't want to say because it's quite standard. I think this is secondary school stuff. The only thing that is a bit tricky is this one. Cosecant square. You need to remember that it's actually negative cotangent. Why? Because again, you differentiate this, you will get it. Right? It's standard. What are those in MF26? Now you refer to MF26, make sure MF26 is beside you. You can see a few formulas there. Okay, you look out for this, okay? Look out for this form, integrate, secant x, tangent x, dx. You look out for integrate, oh sorry, not this one. Integrate tangent x first. I better write down. Sorry. You can look out for integrate tangent x, integrate cotangent x, integrate cosecant x, integrate secant x. So these four are all in formula list. Right? Now, I give you an example. I don't want to write everything. But this one. There are a few things that are not in formula list. The mod sign, not in MF26. The plus C also not in MF26. As long as you see a result with the ln something, you've got to add the mod sign. Right? You've got to add the mod sign. It is not, mod sign is not in MF26. But you don't have to remember. This one is all in formula list. It's just you're going to add a mod sign and a plus C. If you want to know more about why is there a mod sign, I can explain to you in person. So we have that. There are two more. They are also MF26, but you need to deduce. If you look at MF26, that they actually tell you. Maybe I just refer direct to MF26 now. All right, you refer to MF26. Here, under derivatives, you can see that they are listed. That means you differentiate this, you get this, you differentiate this, you get this. In other words, you integrate secant tangent, integrate cosecant cotangent, you will get this one and the rest. So I'll not write in detail, but you should know that you should be able to deduce. You should be able to deduce these two. Integrate secant x tangent x, and you should be able to use integrate cosecant x. So I say again, maybe I look this like this clearer. Alright. Now here, not in MF26, you got to remember 4. In MF26, you have 6, you actually don't have to remember. So don't be overwhelmed. Know what is in, know what's out. Next, what if you face the integration of the form sine square and cosine square? Actually, only one thing. When you see sine square, cosine square, 2 words. Double angle. 3 words. Double angle formula. All you need to know, again, is in MF26. Alright, MF26. Cosine 2a equals to 1 minus 2. Is also sorry. Is also 2. You change this to cosine 2a, and it's easy. I shall not say too much. Alright? Now, this is the form that is slightly trickier. Sine times cosine, sine times sine, cosine times cosine. But let me see how much space I have to write. Okay. It's easy for me to illustrate using one example. Let's say I want you to integrate sine 3x cosine 2x. First, I want to say that this is a product. Correct? Product is very difficult to integrate. If it's a sum, it's a lot easier. I repeat, if it's a sum, it's a lot easier. So here we have to look at MF26. How can we convert a sum, a product, to a sum or difference? If we are able to do that, then it becomes easy. Right? It becomes easy. So let's go to MF26 now. Here, you got look under trigonometry. There are these four formulas here. Now you refer to MF26 while I change back the screen. Let's look at it. Okay. I hope you have an MF26 in front of you. Quote unquote, right here. My MF26, the first line of those four lines, it says sine p plus sine q equals to 2 sine half p plus q sine half p minus q. Unquote. This is in MF26. Okay, alright. There are four lines. This is line number 1, 2, 3, 4. I zoom into line number 1. Why do I look at line number 1 for this question here? It's very simple. You see a sine times a cosine. You see a sine times a cosine. So I will zoom into line number 1. Okay. For the appropriate question, you look at the corresponding line. Our objective is to get from here to here, and let's get into a sum of the distance. How do we do that? Not so simple actually. It looks difficult because your right hand side is p plus q over 2, right? And your left hand side is your p and your q. So the first thing I would do is I would let 3x equals to p plus q over 2. So this is our 3x. The one, then my 2x equals to p minus q over 2, because this is p minus q. I call this equation 2. My objective is to find what is p, what is q in terms of my x. If you can do that, then it's well and good. Right? So, can I say equation 1 plus equation 2? My left hand side becomes 5x. Right hand side is just a p. Equation 1 minus equation 2. My x, this minus this, I'm left. So, actually, this one is just my 5x. This one is just my x. So, I can able to rewrite this as half. Why is there a half? Because there's a 2 here. I divide both sides by 2. Yes, then I get half sine p is 5x, plus sine q is my x. Now you tell me, is it easy to integrate? Because I have a plus. So as long as you can have a sine times a cosine, see sine times cosine, sine times sine, cosine times cosine, you can use each of the corresponding lines to convert it to a sum or difference. Now, do we have to always do this step? I leave it up to you. It's fine. You can leave it. You can do it every time. You don't, because you always spot the pattern and you realize that this is my 5x. If this is my, or rather, this is my 3x. This is my 2x. This will always be this guy plus this guy. The q will always be this guy minus this guy. This manipulation will always be the same, whether it's for line 1, 2, 3. I repeat one more time, maybe just to be very, very, very clear. This and this is always take this plus take this will always be P. Same thing, take this plus take this will always be P. I take this minus this will always be P. Standard. Always. So I leave it to you whether you want to always do it or not. So that sums up the trigo bit actually. Right? That sums up the trigo bit. In essence, the standards form, you must know the 4 standard memorized. Those not in MF26. Sine square, cosine square. And you have this making use of factor formula. Next, we talk about this form. I simplify by saying this is 1 over quadratic. And it's 1 over square root. Here, you got to refer to MF26. Okay, because we produce MF26 here. There are 4 formulas here. Integrate 1 over x squared plus a squared. Integrate 1 over square root a squared minus x squared. Integrate 1 over x squared minus a squared. Integrate 1 over a squared. These are the 4 in the formula list. Now I want to emphasize one very important thing. You can replace x with x plus k, and your formula all still works. Why? Because if I say this is like that, means I differentiate this, I will get back this. So imagine if I replace x with x plus k, I use chain rule, I differentiate x plus k once, I will still get 1. I can still replace this with x plus k. No big difference. But I cannot then it's clearer. Right? But I cannot replace x with ax. A can be a constant. I cannot replace a, maybe not a, like bx. Should I use a? So example, if I want to integrate 1 over 3x squared plus 2 squared, I cannot use this outright. I got to do something. I cannot use this formula blindly. Clear now? Yeah. So I would do some manipulation. Later we can, in the questions, we can actually take a look. But I want to emphasize that you cannot replace x with bx. So how do we integrate something like that? 1 over quadratic, 1 over square root quadratic. Change my pen color first, huh? Now, I think it's easily illustrated using an example. Right? But I just use one example. Right? So I give you an example. What if I want to integrate 1 over x squared to x? Now, your objective is to cast it into one of the form 1, 2, 3, 4 from MF26. Yes? It looks like it's 1, but here you have a plus 2x. This is given. The keyword here is you must. Sorry. You must complete the square. So after completing the square, by hook or by crook, you do it. If you want to go through, you get this. When you get this, then you can refer to this one. 1, 2, 3, and in our case, we look at equation line number 1. Maybe I refer you very quickly to example 26 now. Which line am I talking about? I'm talking about under integral. Here. It's 1, 2, 3, 4. 1 over quadratic. Alright? See. You just refer. Again, as long as you see a ln, you change it to mod. Ln, change it to mod. You can make some notes on your own formula list just to help you learn. Alright? But don't blanco it. Make the correction in red. Okay? Make the correction in red and make a star there. So that you are conscious that every time you see the ln, you need to change it to mod. So in our case, we're going to look at this line by our example. Alright? Let's see this example. Here, let's go back to this example. 1 x plus 1 square plus 1 square. You look at here, you can replace x with x plus 2. So therefore, it is 1 over 1 tangent inverse x plus 1 over 1 plus c. Therefore, it's just. Of course, it's an easy example, but you get it. Alright? For the rest, it's like now, last bit. What if it is the numerator is not a 1? It is an ax. I think it's easiest to solve using an example. What if it is a 2x plus 3 over, maybe I shouldn't get like 2x. Maybe I should use another example. X plus 3 over x squared plus 2x. Alright? Recall in our earlier example, we knew how to integrate 1 over x squared plus 2x. It's one easy game already. Refer to you can rewind the video and realize that this is. But this is not 1, this is a linear. Can we break it up? But when we break it up, we must be very conscious. How are we breaking it up? Now, do you agree with me that if I'm saying if you ask me to integrate this one, this is also easy. If the numerator is not x plus 3, the numerator is 2x plus 2, it is also easy. Why? Because it's of the form integrate prime x over x. So we are going to make use of these two ideas, these two easy things, and going to put it here. How to solve this one? If I can express this as something a times 2x plus 2 plus b, where a and b are constants to be found, then I break up the integral, then I can solve. So to be more specific, I'm going to do this. Right, I'm going to erase that. Very good. Erase. I'm going to do this. Is it obvious? I'm going to do this. This is the same as integrating. I rewrite x plus 3 like this. It's actually half 2x plus 2 plus 2 over x squared plus 2x. Where just now I said this is my a. Don't ask me how come I can find these two so fast. You can actually do it slowly, doesn't really matter as long as you get there. The objective is to rewrite x plus 3 equals to a to x plus 2 plus b. Dot dot dot, you realize that you can find a is half, b is by hook or by crook to get there. Now, why do I want to rewrite in this form? Because this is my f prime x. This is very important. This is fixed. This is fixed. You cannot change this guy because if the denominator is this, your f prime x must be this. Then this v can be anything. It doesn't really matter. It's just a number. Now the magic comes in the next step. It's actually half integrate x plus 2 x squared plus 2x 2 plus 2 integrate 1 over x squared plus 2x. I don't think I need to continue anymore because this is of the form f prime x over fx. This is what you have done earlier. You rewind the video and you know what I mean. It's easy. So let's focus on the big picture here. The big picture is if you get something, if your numerator is a linear expression, your denominator is the quadratic, aim towards splitting it up into two easy forms. Find your A. Right? I hope that's clear. It should be 90% comprehensive. Of course, there are more other difficult questions, but I think this should get you through 16.1, 16. Thank you.